Today in this part of program we will discuss about PPI, that is programmable peripheral interface. Actually it is a interfacing chip used with the different microprocessors for the interfacing of IOs. The Intel 8255 or PPI is a programmable peripheral interface. It is an IO port chip used for interfacing of IO devices with microprocessor. It is a very commonly used peripheral chip. The knowledge of 8255 is essential for engineering and other students for performing various interfacing practicals in laboratories. Now let us discuss some key features of 8255. The 8255 is a popular interfacing component that can interface any TTL, that is transistor logic compatible IO device to a microprocessor. It is used to interface to the keyboard and a parallel printer port in PCs, usually as a part of integrated chip. The PPI has 24 pins for IOs that are programmable in group. These 24 pins are available in PPI in the form of 3 ports, namely port A, port B and port C. As the total pins are 24, each specific port, that is port A, port B and port C, has its own 8 lines. Now let us see the basic pin layout of 8255. The 8255 is a 40 pin peripheral in which there are 24 dedicated IO lines divided into 3 ports, that is port A, its lines are PA0 to PA7, then port B, its lines are PB0 to PB7, and similarly port C, its dedicated lines are PC0 to PC7. Then there are 8 dedicated data lines D0 to D7. Then there are some another lines like read bar, write bar, A0, A1, reset and chip select. Then we have 2 more lines, that is VCC and ground lines. This 40 pin peripheral is used widely for interfacing the various IOs with processors. Now for this 8255, the most important lines for selection of the different ports and the control word register of 8255 are A0 and A1. These lines may have possible values like 00, 01, 10 and 11. Depending on the status of A0 and A1, the various ports or the control word register of 8255 is selected. Like if A0 and A1 are 00, then the port A is selected. Similarly, for 01 port B is selected, for 10 port C is selected, and for 11 the control word register or the command word register of 8255 is selected. This command word is responsible for the initialization or the programming of 8255. So whenever we go for the programming of 8255, first we have to program the command word of 8255. Now let us discuss this command word or the control word of 8255. It is actually an 8-bit register with the bits marked as D0 to D7. Each specific bit of control word has its own function, like the D0 is responsible for PC lower. Similarly, D1 is for port B, D2 is for the mode selection of port B, D3 is for port C upper, similarly D4 is for port A, then D5 and D6 are dedicatedly used for the mode selection of port A, and the D7 is used for the master mode selection. The 8255 can be programmed in either a IO mode or the BSR mode. IO mode is selected when D7 bit is 1 and the BSR mode is selected when D7 bit is 0. We will discuss these later. let us see the basic definition of the various modes used in 8255 in IO mode. Actually in IO mode there are three sub modes, that is mode 0, mode 1 and mode 2. Now let us see what are these different modes, like this mode 0, mode 1 and mode 2. First of all, the mode 0, it is known as the basic IO mode. In this mode all the three ports, that is port A, port B and port C. Actually this port C can further be divided into two parts, that is PC upper and PC lower. PC lower has 4 bits, that is PC 0 to PC 3, and PC upper has again 4 bits, that is PC 4 to PC 7. So in all we can say that 8255 has 4 ports, 2 are 8-bit ports, that is port A and port B, and 2 are 4-bit ports, that is PC upper and PC lower. Now again we come back to this mode 0 operation. It is known as the basic IO mode. Basic IO mode means in this type of mode all the 4 ports of 8255 works in simple input or output mode. Any of the port can work as a input port or any of the port can work as a output port. Then next we come to mode 1 operation. This is known as strobe IO mode. Strobe means controlled IO mode. In this type of mode, that is in mode 1, the port A and port B works as the IO port, but the port C acts as the control port. Now what is the meaning of control port? Control port means the whatever work is being performed by port A and port B. Work means either port is acting as an input port or the port is acting as a output port, but these input port or the output port will be controlled by port C bits. Dedicated bits are assigned for the particular operations. So we can say in mode 1 operation, port A and port B are IO ports, but the port C is the control port. Hence the name is given strobed IO mode. Now next we come to mode 2 operation. This mode 2 operation is known as bidirectional bus strobed mode. This mode, that is mode 2, is defined only for port A for bidirectional functioning. Bidirectional means port A can receive the data as well as port A can send the data. Port B will work either in mode 0 operation or in mode 1 operation, but the port C will act as the control port. So these are the 3 modes of 8255 for master mode IO, that is mode 0, mode 1 and mode 2. Now let us discuss the control word for IO mode in detail. As we have seen, the command word or the control word is of 8 bit. Now let us see the definition of each bit in detail. The command word is 8-bit register. The D0 bit is used for port C lower. If this bit 1 is 1, then port C lower will act as the input port, and if this bit is 0, then PC lower will act as the output port. Then the D1 bit, it is used for port B. Again, if this bit is 1, then port B will act as the input port, and if this bit is 0, then port B will act as the output port. Then the bit D2, it is dedicatedly used for mode selection of port B. If this bit is 0, the mode of port B is mode 0, and if this bit is 1, then the mode of port B is mode 1. Then we come to bit D3. This is dedicatedly used for port C upper. Again, if this bit is 1, then port C upper will act as the input port, and if this bit is 0, then port C upper will act as the output port. Now we come to bit D4. This bit is dedicatedly used for port A. If this bit is 1, then port A will act as the input port, and if this bit is 0, then port A will act as the output port. Next, the bit D5 and D6 are used for mode selection of port A. Now, why we are using 2 bits for port A mode selection? The reason is that the port A can be used in mode 0, in mode 1 and mode 2. So we need 2 bits to define mode 2. Now if the D5 and D6 are 0 0, then mode selection for port A is mode 0. If these bits are 0 1, then mode selection for port A is mode 1, and if these bits are 1 and don't care, means the bits may be 1 1 or the bits may be 1 0, but the mode selected will be the mode 2. And the last, that is D7 bit, if this bit is assigned 1, that is single 1, then our master mode is the IO mode. So this is all about the control word for IO mode. Now let us see the control word for BSR mode. Now let us first see what is actually the BSR mode is. It stands for bit set reset mode. This mode is defined only for the port C. That is, the individual bit of port C can be set to 1 or it can be reset to 0 by programming in the mode, that is BSR mode. Now let us see the control word register for BSR mode. Again, it is a 8-bit register and each bit has its own definition. The bit D0, it is used for deciding that whether we want to set the bit or we want to reset the bit. To set the bit, the D0 bit must be 1, and to reset the bit, the D0 bit must be 0. Next, the D1, D2 and D3 position bits are used for the bit selection. Bit selection means that which bit of port C we want to set or reset. Obviously, when there are 3 bits, that means using 3-bit combinations we can define 8 different values starting from 0 0 0 to 1 1 1. If D1, D2, D3 are 0 0 0, that means we want to set or reset the PC0. Similarly, if it is 0 0 1, we want to work on the PC1 and so on. Then after, the D4, D5 and D6 bits of the control word registers are don't care conditions. That means we can assign either a 0 or 1 to these values, but they will not affect the functioning of our mode. Then last, that is D7 bit, it will be definitely 0 as we are working in the BSR mode. In case of IO mode, we have set the D7 bit. In case of BSR mode, we will use 0 at the position of D7 bit. Now let us see the basic building block or the internal block diagram of 8255. As we can see, there are 4 different ports: port A, then port C upper, port C lower and port B. Obviously, port A is a 8-bit port with its lines as PA0 to PA7. Port C upper has its 4 dedicated lines, that is PC4 to PC7. Then port C lower, it has its lines as PC0 to PC3, and again a port B, it has its 8 lines, that is PB0 to PB7. Now there is a block known as group A control. This block is responsible for the controlling of port A and PC upper. Similarly, there is another block known as group B control. It is responsible for controlling the port B and the PC lower. Then we have data bus buffer, to which the dedicated D0 to D7 data bus is connected. Then we have a read write logic, which has the signals read bar, write bar, A0, A1, reset and chip select. Chip select is responsible for the selection of this 8255 for programming and interfacing purpose. Then we have 2 lines, that is VCC and ground. This 8255, as it is compatible with TTL, it works on plus 5 volt supply. Now let us see how the various ports are selected during the programming or the interfacing of 8255. The various port selections or the control word register selection is done with the help of the lines A0 and A1. As we can see, the lines A0 and A1 can have 4 different combinations, that is 00, 01, 10 and 11. When A0 and A1 are 00, then we are selecting the port A. Then 0-1 combination will select the port B, 1-0 combination will select the port C, and 1-1 will select the control word register or the control port. Now let us see the basic diagram in which we are showing how the chip selection works. Here a hardware is implemented over a chip select line. Here the line A7 is 0 and remaining A6, A5, A4, A3, A2 are 1. Now the A0 and A1 will be decided that how we want to select the port. If we want to select port A, then A0, A1 will be 0, 0. Similarly for port B it will be 0, 1 and so on. So we can say that using the proper hardware for chip select and using the various combination of A0 and A1, we can compute the port addresses for the different ports. Like in this case, the port addresses will be 7CH, 7DH, 7EH and 7FH for port A, port B, port C and control word register respectively. Now let us discuss in detail the modes that we have already discussed, that there are two master modes, that is IO mode and BSR mode. Now in IO mode, let us first take the mode 0. It is known as simple input or output mode. In this mode, port A, port B are used as simple 8-bit IO ports and port C as two 4-bit IO ports. Each port can be programmed to function as simply an input port or an output port. The input output features in mode 0 are as follows. Outputs are latched, inputs are not latched, ports don't have handshake or interrupt capability. Now what is this handshake or the interrupt capability? Handshake means whenever a process is to be run, first its request is being received and then its permission is granted. So as we are saying that ports don't have handshake capability in mode 0 means there is no request or grant condition in mode 0. Similarly, the ports don't have interrupt capability means the interrupt driven data transfer is not possible in case of mode 0 operation. Now let us see the mode 1 operation. It is known as input or output with handshake or the strobed IO. Input output with handshake means the process is governed by request and grant. In this mode, handshake signals exchange between the microprocessor unit and peripherals prior to the data transfer. The features of this mode include the following points. Two ports, that is A and B, function as 8-bit IO ports. They can be configured as either a input port or the output port. Each port uses 3 lines from port C as the handshake signals. The remaining 2 lines of port C can be used for simple IO operations. Input and output data are latched. Interrupt logic is supported. That means the interrupt driven data transfer is possible in this mode, that is mode 1. Now let us see the mode 2 operation. It is known as bidirectional data transfer for port A. This mode is used primarily in applications such as data transfer between the two computers. In this mode, port A can be configured as bidirectional port, port B either in mode 0 or mode 1, and port A uses 5 signals from port C as handshake signals for data transfer. The remaining 3 signals from port C can be used either as a simple IO or as a handshake for port B. So we can say that mode 2 is a bidirectional control mode of data transfer. In this, port A is used for bidirectional data transfer, port B can be in mode 0 or 1, and C acts as the control port. Now let us see what are the handshake signals and where these handshake signals are present actually. The port C pins acts as the handshake signals. When port A and port B are configured for other than mode 0, that is either in mode 1 or mode 2. Port A in mode 2 and port B in mode 1 is possible as it needs only 8 handshake signals. After reset of 8255, port A, port B and port C are configured for mode 0 operation as input ports. PC2 to PC0 are used as handshake signals by the port B when configured in mode 1. This is immaterial whether port B is configured as input port or as a output port. PC3 to PC5 are used as the handshake signals by port A when configured as input port in mode 1. Similarly, PC3, PC6 and PC7 are used as handshake signals by port A when configured as output port in mode 1. PC3 to PC7 are used as the handshake signals by the port A when configured in mode 2 operation. Now let us see the overall operations in brief explanation again. The port A can work in mode 0, mode 1 or mode 2. Port B can work in only mode 0 and mode 1. Port C can work in only mode 0. Port A and port B and port C can work in mode 0. Port A and port B can work in mode 1 and only the port A can work in mode 2. So we have seen that how the 8255 and its 3 ports, that is port A, port B and port C, and further this port C divided into 2 parts, that is PC upper and PC lower, can be programmed in different modes using their control word registers. So in today's program we have discussed about the 8255, that is programmable peripheral interfacing chip. We have seen that this chip has the different ports and all ports are programmable. These ports can be programmed using the control word register of this 8255. Programming can be done in varieties of manner, like we can make a particular port as an input port, we can program the port as an output port, or we can even program the port as the bidirectional port. We have also seen that the overall operations are controlled, that is we have seen the strobed mode. The port C we have discussed is used for the controlling the overall data transfer operations. I hope you all have enjoyed this session of 8255. Thank you.